Hey, this is Jesse with createthis. So today I'd like to talk about two different ways to control LED brightness. So LED dimming, basically. First, I'll show you the most straightforward way. So the most straightforward way to dim an LED is to reduce the current going to the LED, or possibly the voltage, or both. So first, here's my LED strip. This is I think these are 50/50 SMD LEDs. I actually bought these at Radio Shack. They come in a long strip. This is actually the kind of packaging that they come in. It's supposed to be like waterproof or something, I don't know. They were fairly expensive. I think I bought them maybe a year or two ago, and they were fairly expensive at the time. They've come down in price, if you know where to get them, quite a bit. So I'm going to provide a link for all of this stuff that I show here today down in the description, and if you want to buy it on Amazon, it won't cost you a dime, but if you click the link and buy it through me, I get a little kickback and it helps me support the channel. So, and plus, you'll get these quite a bit cheaper than I bought them. I think they're going for like $9 or something these days, so I think I bought mine for like 30, so, good deal there. Anyway, I'm not going to go over how I made this panel, but basically, I've got two leads here for positive and negative, and I've just got them joined in series here, okay? And then this last one is not joined to anything, and that's just the way the circuit works. It flows all the way through and then back to the negative lead there. So anyway, let me show you that. Let me prove. This is a 9-volt battery here. Let me prove to you that this works first, and then we'll dim it. Okay. So I'm just going to connect my alligator clips here on the positive end of the LED and the positive end of the battery. Oh, got the insulation there. Positive end of the battery and negative end of the LED and negative end of the battery. Okay, and then I've got a switch right here. I'll just turn it on. Instantly bright, right? But what if we'd like some control over how bright it is? So the simplest thing that I could come up with for this, and there are, like I said, there are two ways to do this, but the easiest and most straightforward way is to simply add a resistor. And in this case, this is a potentiometer, so it's a variable resistor. It's got this knob right here, and as we turn the knob, we can vary the brightness. So I'll show how that circuit works next. So we just attach the positive lead to the battery here, and the negative lead, here. Other positive lead to the middle terminal on the potentiometer. I don't remember why it's got 3 terminals at the moment. Can probably look that up later. Attach that to the positive lead on the LED. Negative lead on the battery to the negative lead on the LED. All right, so now when I turn it on, you can barely see that it comes on just ever so slightly. And as I increase the voltage here by the voltage and the current by twisting this potentiometer, you can see that I can vary the brightness. Now, just to give you a little bit of backstory, the reason why I built this thing is because I wanted, I had these 3D printed lithophanes, and they're basically, like an image printed in height map, right? And so what you can do with this is you can put it over this backlight, and you can raise and lower the brightness, and the image becomes clear. And the further you are away, the better the diffraction is, so it's a little easier to see. There we go. So that's maybe an inch away from the back of the LEDs, so I could put that in a box, and that would look pretty awesome, right? Now, what's going on here in this circuit? This is a resistor. I already mentioned that. This is the battery, and that's the LED, right? What happens is when you put a resistor into a circuit, it modifies the amount of current going to these LEDs, and it also modifies the voltage. Now, I can show that, I can prove that to you with a multimeter. should always have a multimeter if you don't have one. This is kind of an expensive model. I have two of these, not two of the, this is a Fluke 87. I've got a Fluke 87 and I've got a X-Tech. I think it's a 430, X-Tech 430. The X-Tech is much cheaper. They both do pretty much the same thing. I think the Fluke 87 has some additional features and it's probably easier to use. So I'll provide a link to both of these in the description. But today we're going to be using the Fluke 87 because I just bought it and I want to play with it. Okay, so let's see. First thing we should do is we should take a look at the voltage. That'll be the most interesting thing for me right now. So to do that, I'm going to measure the voltage at these two leads because this is the LED. This is where the LED is seeing the voltage after the resistor because it flows through the circuit, flows through the resistor, so I'm going to measure it right there. So first thing I'm going to do is I'm going to attach my negative lead from the multimeter. All right, and second thing I'm going to do is I'm going to attach my positive lead from the multimeter. Okay. And you can see that it's already registering 7 volts, and then as I vary the potentiometer and I increase the voltage, look at that, 7.2, and you can see the LEDs are getting a little brighter, 8.6, and that's about where it tops out at, 8.6. So pretty interesting. Now, what's also happening is it's varying the current. So let's take a look at that. We will switch this off for a second. And this time what I'm going to do is I'm going to put the multimeter in line in the circuit. I'm really not an expert at this, so there might be a better way to do this, but this is what makes sense to me at the moment. So I'm going to turn off my battery for a second here. And let's see. Positive end to the negative end. And then negative end to the positive end. Okay. We'll turn that over to the milliamp rating. And, you know, these are fused, right? This is a 400 milliamp fuse here. I have tested this previously on the amp rating because I didn't want to blow my fuse, and it's definitely not going to make 400 milliamps, so I'm sure there's math you can do for that too. But all right, switch that over to DC amperage. Okay, turn on the voltage. Oh, I've got it backwards. It's displaying a negative voltage. Okay, sorry. Switch that around. Yeah, no, that's why it's displaying a negative voltage. I've got it on the negative lead. That was, or a negative amperage. That was silly. Okay. Now if we turn that on, there we go. Now we've got 0.10 milliamps. Now if I raise the, if I turn the potentiometer here and I make the LED brighter, 2.8 milliamps. 27.4 milliamps, 85, 83 milliamps. See what's happening there? So that actually varies the current quite a bit more than it varies the voltage. So anyway, that's the first way to dim LEDs, okay? Now the problem with this is it's not very efficient. Go ahead and turn that off, save my battery. What happens is resistors, the way they work is they generate heat. So everything that flows through them turns into heat. So this is a wasteful way to dim LEDs because you're getting a lot of waste in the form of heat from this potentiometer. So now I'm going to show you a more efficient way to dim LEDs that kind of plays tricks on your eyes. So now I'm going to show you how to dim an LED using what's called pulse width modulation, or PWM. This is the other alternative for dimming an LED. Now the advantage of doing it this way is that it is more efficient. It uses less electricity. See, LEDs have this big advantage. They can turn on and off extremely quickly. faster than our eye can see. So that allows us to play some tricks on our brain. Now, what I've got here is a tutorial for an Arduino. I actually, the first time I ever did this was for my kids, like I mentioned before, and I wanted to, I just raised a question to them. I was teaching them how to use an Arduino, and I was teaching them how to program, and I said, so how would you dim an LED? And none of them could come up with an answer. So we looked it up online, and there's a tutorial here. And it requires an Arduino board, it requires an LED, and it requires a 220 ohm resistor. It also requires a wire. And so in our other camera view here, here's our Arduino Uno. There's a 220 ohm resistor right there. There's a wire, blue wire, and there's our LED, and this is a breadboard. So to give you an overview of the setup, there's the Arduino and the breadboard. I've got a USB cable, and it is going into my laptop. And on my laptop, I'm on the tutorial page, and let's see here. So they've got a schematic, and that shows you, what you need to know about the connection. I prefer a more electrical schematic, but whatever. The important thing here is that this end of the LED is the long end of the LED. The long end is always positive, and pin 9 is PWM on the Arduino. The other end, the short end, goes to ground, so that's the negative end, okay? They give you a schematic, but eh. And then they give you some code, okay? And this is weird because they've got all of this processing code like commented out, so really all you need is this stuff up here. But here's the thing, the way they wrote this, it takes a single character as input. And so it's using like ASCII values. So like maybe like the letter O is like 80 or something, and like the letter Q is like 10 or something like that. I find that very confusing. It is the most simple way to write the program, but I don't like it. So what I did is I modified this, and I will provide a gist in the description below that lists out all this code, so you can just copy and paste it into your Arduino IDE. And what I've done here is I've done a couple of things. First, I bumped up the serial speed. That's not really necessary. I just did that because I was screwing around. I printed a prompt out on the first iteration of the loop. So I'm giving you brightness 0 to 255. Okay, so you can pick how bright you want the LED to be. And then I am reading not just one character, but I'm reading multiple characters, and I'm kind of amalgamating them into this brightness string. Right? I'm concatenating them into this brightness string. And then I'm analog writing to the LED pin, which is pin number 9. I'm analog writing the brightness string as an integer. So I'm converting it to an integer here. Okay? And then I'm printing out the brightness value, just so that you can, have some confirmation that that's actually what's happening. So let's see this bad boy in action. Let's see what happens here. So we've got our LED. It's on. Actually, let's restart this sketch here. I'll re-upload it, and you can see what happens from scratch here. So our lights flash. That means that the sketch has been uploaded. The LED is off currently. On the terminal screen, and you get to the terminal screen. Let me show you how you do that. You get to the terminal screen by going to Tools and Serial Monitor. Okay, and what I've done is I've set this to new line, and I've set this to 19200 baud. Okay, those two things are important. Make sure you do that when you run this sketch. And now it gives you the prompt, brightness 0 to 255. Okay, so let's do 10. That's going to be pretty dim, right? And now you can see the LED has turned on. Okay, let's go to 255. That's pretty bright, right? Okay, so that's full brightness. Let's go to 80, somewhere in the middle, right? Did it get a little less bright? I wasn't paying attention. Maybe it did, maybe it didn't. Yeah, it got a little less bright. 80 gets it a little less bright. 30, even less bright. 10, less bright. How about 1? 1's very dim. You can barely see any light on at all. Okay, and 0? Is 0 off? Yeah, 0's off. Okay, so that's how this sketch works, right? Now, what is actually happening here? how are we, you know, is this varying? This isn't a variable resistor, this is a set resistor, right? So how is this varying the voltage and the current? Well, the answer is it's not. Instead of varying the voltage and the current constantly, like the potentiometer did in the last example, it's varying the voltage and the current over time. So basically what it's doing is it's switching on and off at a very high speed. And the width of the time that it's on, the amount of time that it's using like a set frequency, like I think it's 490 hertz, close to 500 hertz, right? So on and off 500 times a second roughly, right? And what it does is, when you set it to say 1, okay, the width of that pulse is very narrow, okay? It's only on for a very short period of that 500 hertz pulse. Now, if I set it to 255, the width of that pulse is full, right? So that it's just a straight line. It's a straight, you know, it's a constant amount of current that's fully on. There's no off time in that cycle, okay? Now, if I set it to 80, which is somewhere in the middle, or, you know, say 30, did that change it? Yeah, it did. Okay. All right, so if I set it to 30, what happens is that pulse gets narrower. So it's on for, you know, not 30% of the time, but it's on for, you know, a short period of time, and then it's off for most of the time in that hertz pulse. Now, that's hard to visualize, right? Let's see. In the tutorial here, I believe, did they give you some info about that? No, they don't really explain PWM. So it's kind of hard to figure out from the tutorial what's going on here. Now, I have a new toy. I have an oscilloscope. And what this oscilloscope is going to allow us to do is it's going to allow us to peer inside the circuit and actually see what's going on in that pulse duration. So let's hook this bad boy up. All right, so what we've got here is a probe. We've got a probe right there, connects to the oscilloscope. So this is the positive end of the probe, and this is the negative end of the probe. And I'm just going to attach this to our circuit. Kind of hard to do with cameras here, but we'll manage. So the positive end of the probe is going to go to right there on the resistor, on the LED, and the negative end of the probe is going to go to the other side of the LED. Okay, so we're going to peep on what's happening inside this LED, or rather, more accurately, we're going to peep and look into what kind of voltage it's getting. Okay, so what I'm going to do, I've got my oscilloscope here. What I'm going to do is I'm going to hit the auto button right here. And as you can see now, it has displayed a waveform. And so you can see that there's a fairly large duration of time here where it's off. Like this is on up here at the top, and this is off down here at the bottom, right? So there's a fairly large period of time where it's off, and then there's a fairly short period of time where it's on, okay? Let's take our Arduino serial console, and let's change that to 80. It was on 10 or 30 or something before. Let's change that to 80. Whoa, cool. So what we've done here is we've increased the duration of the pulse. You can see down here at the bottom, the frequency is the same. So the frequency is 490.2 hertz. Okay, it hasn't changed. I'll do that again. I'll go down to 10. All right, it still says 490.2 hertz. Then I'll go back up to 30. And then 80. So you can see the start of every pulse is exactly the same. It's in exactly the same place. But what we're doing is we're increasing the duration of the pulse. So we're turning it on longer. And then if I go up to, let's say I go up to 200, right? Look at that. So now it's on more time than it's off. And what happens to the LED? The LED is brighter because of that. So our eyes are being tricked. This LED is actually being turned on and off on a frequent basis, and our eyes can't see it. We instead see the average of that. We see that it's mostly on or it's mostly off, and we interpret that as brightness. So photography works the same way. You can do the same thing with a camera. It's called a long exposure, but that's another subject. So what happens when we turn this all the way on? 255. Whoa, straight line, right? So that's constant current. That means it's on all the time. What happens when we turn it off? You see, constant current was up here. Constant no current at all is down there. So that's, we're displaying voltage here, right? All this is showing is that the voltage was high and then the voltage was low. And then if we turn this on with a 1, we see we've got a teeny tiny little spike right there. We go up to 50, the spike gets wider. Pretty cool, huh? So, yeah, when I explained this to my kids, I had to do all of this with, you know, a pen and paper and a notepad. And, you know, I mean, it works. You can explain it that way, but having an oscilloscope is so much better. You just, you know, you get instant gratification. You can see immediately what's going on inside your circuit while it's running even. So, yeah. Most professional dimmers, like I've got a video on Lutron cassetta dimmers for household wiring, you know, household LED lights. Like if you want to replace a bulb in your kitchen with an LED bulb and you want to dim it, most of the professional dimmers that you can buy these days, like in the Lutron cassetta line, they're called C.FL dimmers. They use this. They use PWM. The older style dimmers use the potentiometer trick, right? So the older style dimmers are actually going to be wasting electricity because they're going to be literally burning it, right? The electricity is turning into heat inside the potentiometer. So when you dim the LED with a, I think they called them triac dimmers. When you dim an LED with an old triac style dimmer, you're not actually saving a lot of energy. You're burning it in the form of heat. So this is why people go with the new style LED dimmers, because the new style LED dimmers use PWM, and as you can see on our oscilloscope, it's saving you electricity because the LED is off for the duration of the pulse. And that's how they work. That's why you save money with LED specific and CFL specific dimmers rather than triacs. So good information, cool to know. I'm going to include links to all of this stuff in the description down below. So if you want to pick up any of these items that I've played with here today, you know, want to have a little science experiment with your kids, or you know, you've got a project in mind or something, click the link down below. Again, if you buy it from me, it doesn't cost you a dime extra. It just, you know, gives me a little kickback, a little commission, and helps me support the channel and continue to buy cool new stuff like this amazing oscilloscope. And yeah. So one more note about the oscilloscope here. This is a Rigol DS 2072A. Okay, this is a 70 megahertz oscilloscope. It's 2-channel. Yeah, I don't know how to say that. 2 GSA/S. It's a very good oscilloscope. It's about $800. There are cheaper ones. There's like a 50 megahertz oscilloscope. I think it's the DS 1052A or something, or 1057A. I'm going to include a link to that one too. They're both excellent oscilloscopes. In my opinion, the reason why you would want to get this one instead is because, and I'm not going to show this here, I've never done it before, but this one is software crackable. If you crack it with software, you can actually upgrade this from 50 megahertz to 300 megahertz. And as far as I know, it doesn't, you know, there's no trace of it. I think you use like a Raspberry Pi or something with the either the USB port or the LAN port. I don't know. There are details on EEV blog that website. So yeah, so for $800 you can basically get yourself the capability to use a 300 megahertz oscilloscope if you need it. You know, if you're a professional and you're doing this all the time, I really would recommend you just pay for a 300 megahertz oscilloscope if you need it. I think you'll get much better mileage that way. But you know, I bought this one because I don't know if I'm going to need it or not, right? I mean, I'm not really quite sure what I'm going to be doing with it. I've wanted an oscilloscope since I was a kid. Now I have one, and I'm not really sure how much, you know, how fast I need it to go. Probably I'll never need 300 megahertz, and I'll never even bother cracking it. But it's nice to know that that option's out there if I need it. So yeah. So I'll include a link to this one and also the less expensive one that does pretty much the same thing but isn't upgradable. So yeah. So yeah, this is Jesse with createthis. If you learned something today, if you found this useful, please click the like button, please click the subscribe button, and thanks for watching.